Division Ground Control. Good morning. First trial of the day will be a ground launch firing from the eastern area at 10 o'clock. Telemetry X-ray, Charlie, Lima, Sierra Band, silence is now in force for pre-firing preparation. Sequence held at -8 seconds. Next pip will be -7 seconds.
A guided missile blasts off from one of the most up-to-date and versatile firing ranges in Western Europe. An outstation of the Royal Aircraft Establishment Farnborough, Aberporth is located at the southern end of Cardigan Bay on the Welsh coast. The whole area, with its surrounding airspace, is overseen by the range's extensive instrumentation, which can acquire, store and analyse performance data. The range can provide a variety of sea and air targets to be fired at from ground, sea or air. Airborne targets come from the range's own airfield at Llanbedr, 40 miles away to the north. Covering about 1,000 square miles, the range is a vast open-air laboratory of unlimited height where a wide variety of experiments can be carried out, from simple calibration flights to complex guided weapon trials. Any range is a potential danger area, so naturally there are strict procedures and well-defined boundaries. The airspace is strictly controlled, but on the coast nearby, people can carry on unhindered by trials activity, because any area where debris may fall is always checked to see that all's clear for a trial to continue safely.
Probably somewhere in this sort of area. This should give us sufficient land clearance, and probably, I would imagine, the instrumentation will probably be...
All experiments assigned to Aberporth become trials and entail a great deal of planning. Meetings are arranged between range specialists and the range users who will sponsor the trial.
Can I ask you to tell us what you're looking for out of this particular experiment?
Yes, I think our requirements can be summarised quite briefly. We shall require air telemetry. We shall want trajectory.
These meetings will determine instrumentation and data requirements and define such things as safety areas and the flight paths of missile and target.
Only insofar as the exercise seems to be taking place up around the OP-10 area, there's a shortage of instrumentation. There is another OP, though.
The planning stages often extend over a long period, especially with new experiments or new weapons, which can mean that new procedures or even new equipment would have to be developed.
Two kidneys on the ship and then on the missile, and those two kidneys after interception go back on...
From these discussions will emerge the specification for the trial, which includes a written trial sequence. This ensures that all events and their consequences have been fully considered and allocates individual responsibilities.
But Laurie, we should insist on having 3 kidneys on the missile.
Yes, well, down the range head.
The weather looks good, Ray. Sea state looks good. Could you give us the ship firing this afternoon?
The trial sponsor now negotiates with range controller, who is responsible for day-to-day running of the trials program, coordinating all the trials and deploying range resources.
Let me just check on the time. Hello, Derek. Concerning the ship firing, we'd like to go for 1500 target takeoff. And you'll be putting up a man in Shepherd, will you? Roger, okay. Call sign Foxtrot on primary. And I'll check again with you at 1400.
When the controller is satisfied that the trial requirements can be met, he allocates it a place in the program.
May from 1400 hours.
Okay.
Jolly good, thank you very much.
Met ground. Will you pass mean wind 0 to 60,000 feet and cloud height over the bay?
The hub of range operations during each trial is ground controller, conducting range controller's program with air controller and an in-flight safety officer. A communication network links him with all the vital points of the range, and as soon as a trial is programmed, he begins a series of pre-trial checks. The presence of shipping and aircraft on the range is constantly plotted in the in-flight safety cell. These plots are checked against a predetermined safety area by the in-flight safety officer. He's responsible for the correct application of range instructions, including the destruction of missiles or targets which go astray in flight. Before a trial starts, he checks out the breakup systems, which include one which can command breakup by radio signal or make it automatic if signals are lost. The in-flight safety officer is supported by outside observers who watch the early stages of ground-launched missile flight through screens with simple line-of-sight limits.
Plus 15 seconds.
Ground control code left.
All operations, including safety on the launcher site, are conducted by the range launcher staff, who supervise the final preparations for firing. When there is a missile on the launcher pad, one of them always carries the launcher key, using it in the control post only when the launcher area is clear. The air controller, who is responsible for the control and safety of all aircraft in the area, draws up scaled plots of the flight plans which are required for the trial. These plots provide the flight paths on which the air controller directs target and manned aircraft to predetermined positions in space.
Right, 070.
The conduct of a trial requires many functions to occur at predetermined times, such as switch to internal power, boost ignition, activate instrumentation and other ground facilities. To ensure that each function occurs in the right order and at the right time, automatic sequence equipment is used, controlled by a central timing unit with an accuracy of 4 in 10,000 million, correlating all operational events. Range timing is regularly synchronized to within a millisecond of Greenwich Mean Time, and various outputs are transmitted to instrumentation throughout the range. A pilotless Jindivik returns to base at Llanbedr. The runway is between mountains and sea, so crosswinds sometimes hinder target takeoff. But the local ground control systems can fly them in weather down to 3 miles visibility and 800 feet cloud base. 90% of pilotless sorties are flown by Jindiviks, the rest by meteors. Jindiviks are flown under radio control at anything from 45 feet to 60,000 feet at high subsonic speeds. They can be made to represent larger aircraft by fitting multiple Lüneburg lenses or equipped with transponders and other devices to increase tracking capability. Radio-controlled cameras mounted in the wingtips film miss distance during missile interception. The target aircraft is an airborne instrument platform, and for this reason, as well as economy, it tows a decoy on most trials, and the decoy is the missile's real target. In this case, infrared flares are being loaded into the decoy, which will be trailed behind in flight. Using Canberra aircraft, Llanbedr also flies the Rushton long tow target with similar systems of enhancement. The pilot in the towing aircraft is safe, as the target is about 3 miles away at the end of a cable.
15 seconds to target launch.
Llanbedr also has a supersonic target, the Stilletto, with altitude limits of 2,000 to 70,000 feet. Air-launched from Canberra aircraft, the expendable Stilletto can fly by autopilot to a preset flight pattern. After launch from the Canberra, control of the target is taken over by Aberporth. The main object of every trial is the acquisition of data related to particular aspects of performance. All trials, especially during the development of new systems, must yield sufficient data to compare with theoretical performance. Hence the need for many precise measurements and for extensive instrumentation with staff to operate and maintain it. Instrumentation takes a variety of forms. Perhaps most obvious is the radar, which maintains a continuous sea and air watch over the Cardigan Bay area. Sea surveillance is by 2 radars at the range head and a 3rd positioned at the northern end of the bay. The sea just off the range head is scanned by 3 closed-circuit television cameras, controlled and monitored by in-flight safety staff. Air surveillance extends to 200 nautical miles. With sophisticated signal processing, the displays from this radar effect the initial identification of trials aircraft.
Ground control, confirm that you have understood the brief, that you're ready for an instrumentation.
Subsequent control and measurement of the tracks of ships and aircraft and the continuous measuring of missile or target trajectories is effected by tracking radars.
Radar 1.
Radar 1 ready.
Radar 2.
2 ready.
Radar 3. Radar 3 ready.
The range is not just a shooting gallery where weapons are fired to see what happens. For instance, when these birds are released, they will be tracked for studies of their wing beat frequency and modulation as part of an investigation into migration.
2, 1, now. Right away. Tracking.
The tracking radars are prime measurement tools in every experiment, and they also play an important safety role. Data from the tracking radars is displayed in real time on the automatic plotting tables in the operations building. The permanent records for subsequent analysis of trial results are recorded on magnetic tape. Tracking information is also used to direct the power-driven aerials for telemetry reception. Many of the measurements from weapons or targets during trials are transmitted by telemetry senders, and the receiving facilities at Aberporth include comprehensive recording and display equipment. During and after a trial, a sponsor can be given telemetered information in a form to suit his particular needs. High-speed cine cameras and kinetheodolites, which are used to film missile behavior and measure trajectory, are deployed at a number of optical observation posts at the range head and at vantage points along the coast.
On a QE of 6 degrees, and the line of fire will be 360 degrees.
There are 10 kinetheodolites, which ensures a high degree of data accuracy. It also means that when necessary, the system can track more than one object or cover different parts of the bay.
3 camera. Understood already.
A similar number of high-speed cine cameras record the behavior of missiles during the early stages of flight. Filming rates up to 200 pictures per second produce records on standard 35mm film.
Understood already. 28 kine.
Remote-control fixed cameras can cover any missile launch, filming at a variety of framing speeds. The optical supervisor coordinates and controls all this optical instrumentation, and photographic section can process and handle all trials film.
Confirm 28.
Some trials call for sea targets, so range controller often needs to know the sea surface characteristics and met conditions just above the surface. Data of this kind is telemetered ashore from instrumented buoys moored in Cardigan Bay. Some measure wave height and period, another local wind speed and direction. Tide height and wave direction are measured at the range head. Floating targets are serviced by crews operating from the range's modified stern trawler. The targets can be fitted with optical and radar enhancement devices and miss-distance cameras, all radio-controlled from the range head. The records collected by this formidable array of equipment still have to be processed and analysed into a form the sponsor can use. The data centre at Aberporth does just this. Telemetry data is converted from analogue recording tapes into digital form for subsequent computer processing. The output is written on multi-track magnetic tape. Semi-automatic readers are used to extract data from high-speed cine camera films. A similar projection system enables target camera film to be analysed and the trajectory and miss distance of missiles to be measured with respect to the target. Data from kinetheodolite films is extracted manually and fed into computer terminals. Each film reader has a visual unit which displays the data sent and indicates any errors for immediate correction. Temporary data storage and checking is controlled by a mini computer and the output written on magnetic tape. The main computer used for processing range data accepts inputs from magnetic tape. Outputs from this computer are by line printer, magnetic tape, and offline incremental graph plotter. The trial's results, when processed for sponsors' use, range from positional data to detailed analysis of the interaction between missile and target systems. In addition to the operational capability of the range, there are certain useful backup facilities. Only a few miles away, its own communications airfield gives quick access for urgent visits and consultations. The range's engineering staff is continuously employed, modifying and improving existing equipment and providing new facilities. Accommodation is provided within the establishment for sponsors' staff to work during the period of preparation preceding their trial. The services are regular users of the range, the Royal Navy and Royal Air Force having their own permanent accommodation. The Navy has its own launcher area at the foot of the cliff, where a Royal Naval atmosphere prevails.
Any position not ready, sequence in a missile, channel alpha, left barrel. Stand by, starting sequence, 3, 2, 1, now.
The self-contained naval site simulates shipboard conditions, with Navy personnel able to monitor the progress of their own firings. The Army, too, have been frequent visitors, using the range's facilities for controlled practice to train and develop the tactical use of existing weapons. Before we leave the range, let's eavesdrop on a trial, with the ground controller coming to the end of the trial's brief.
Stop action with Tilly. Number 1, number 2, number 3 radar, in-flight safety, -1 second. CTU to 0 time. Sponsor, Taj Mahal, launch officer and air control at any time.
Up at Llanbedr, a Jindivik is being prepared for takeoff.
And I now check that you have understood the brief, you're ready for an instrumentation check, and that you'll be ready for the firing. Optics.
Optics ready.
Met. Ready.
CTU.
Ready.
Artillery receivers.
Ready.
Radar 1.
Radar 1 ready.
As checks continue round the range, the target aircraft is being fueled.
Flight safety, ground.
Ground in flight safety.
Confirm range is clear for target roll.
Confirm the range is clear for target roll.
Directed by Aberporth's air controller, the Jindivik makes a practice run to the planned intercept position to establish that all posts and systems can meet the trial objectives.
All positions, ground control. We'd like to check stop action, starting with Tilly.
A final check ensures that those positions essential to safe and satisfactory conduct of the trial can, if necessary, stop it.
In-flight safety, ground. Confirm range is clear for a live run.
Ground control flight safety. Range clear.
Sequence held at -8 seconds. The next step will be -7 seconds, live run.
The converging flight paths of missile and target are confirmed by the plotting table pens. The upper pen represents the target. As the missile approaches, the wide-angle lens cameras in the target aircraft are switched on and record the interception.
Intercept. Take up, commanded.
Back at rangehead, quick look records will be produced soon after the trial so that the sponsor can make an early assessment of his missile's performance. The remaining records go to the data center, and the complex work of reducing them to usable form begins. Llanbedr still have to recover their aircraft, and even though the towed decoy was the real target of the missile, vigilance cannot be relaxed. There is some chance that the aircraft itself may have been damaged, so a Shepherd aircraft, which is standing by, must close up and assess any possible damage before it can be returned to base. Happily, this one survives to fly again. Now the range can settle down to some self-analysis. Why did an instrument fail? Can the method of conducting the trial be improved? Range users' requirements are becoming more and more stringent, and the range must keep ahead by constantly striving to improve techniques and reliability in obtaining records.
Of trials for today. Warning of an early trial tomorrow. X-ray 3281 sortie 99 to flight plan 5 will be attempted at 0930 tomorrow.